All right, we're going to pull back the curtain on something we all use, but maybe don't think about nearly enough: the invisible and honestly enormous physical demands of artificial intelligence. When you use an AI, the whole experience feels, well, it feels like magic, doesn't it? You type in a prompt and boom, an answer just appears. It feels like pure software, something that just lives out there in the cloud, infinitely scalable. It's just code, and code is supposed to be weightless, right? But of course, that magic has to come from somewhere. That feeling of infinite possibility isn't just an idea floating around. It's a real service being delivered. So what is it actually running on? What's the machine behind the ghost? Okay, this is where we need to go behind that digital curtain, because it turns out AI isn't some abstract concept floating in cyberspace. It's a physical industry with a massive and rapidly growing physical footprint. So let's just trace that journey for a second. When you send a prompt from your phone or laptop, it travels through the internet to a very real, very physical data center. And look, we're not talking about a few servers in a closet here. We're talking about colossal buildings, packed wall to wall with specialized hardware, all of it running at full tilt. And every single one of those machines is plugged directly into the electrical grid, just sucking down an immense amount of power. And this really gets to a crucial point, which the researcher Kate Crafter captured perfectly. She said, artificial intelligence is not artificial or immaterial. It is physical, it is extractive. In other words, this digital world we love is constantly being pulled right back down into the physical one. So you might be thinking, what's the big deal? All computers use electricity. And yeah, of course they do, but AI is different. See, unlike a simple web search, a single AI prompt can trigger billions, sometimes trillions, of calculations across this huge network of machines. That requires an enormous, and more importantly, a constant supply of power. The very kind of work AI does creates this unique energy bottleneck because of its massive and really specific demand for a certain type of power. Okay, think about it like this. On one hand, you have what's called intermittent power from sources like solar and wind. It's great, it's clean, but it fluctuates, right? The sun isn't always shining, the wind isn't always blowing. AI data centers, though, they absolutely cannot handle fluctuation. They need what's known as base load power. That's a constant, uninterrupted flow of electricity 24/7. Because for an AI system, downtime isn't just an inconvenience, it's a catastrophe. Models fail, services crash, the whole thing grinds to a halt. That's why baseload power, that always-on, totally reliable supply, is completely non-negotiable. It's the absolute lifeblood of the whole operation. And that non-negotiable demand for reliability, well, it dramatically narrows the energy options. The search for baseload power leads you directly to sources like natural gas, nuclear energy, and, yep, in some places, even coal. The simple need for a steady 24/7 supply means a company's choices are constrained long before a single line of software is even written. This is where things get really, really interesting. These physical energy constraints, they don't exist in a vacuum. They create these subtle second-order effects that start to reshape markets, access, and even who gets to hold power in this new AI landscape. I mean, just take a look at this. Building and powering these AI data centers is astronomically expensive. We're talking billions and billions of dollars in capital. As you can see pretty clearly here, this creates a massive barrier to entry. New, smaller players, they just can't compete with the kind of capital that the AI giants can throw around. And that is the core dynamic. The incredible productivity gains we get from AI don't get spread around evenly. Instead, they concentrate power with the very, very few organizations that own the underlying infrastructure, the ones who can actually afford to pay that massive energy bill. The consequences of this are profound. You see higher barriers for startups, you see a consolidation of AI development in places with cheap, reliable energy, and for all of us as users, it creates these hidden dependencies on physical systems that we have absolutely no control over. This is the kind of stuff you will never, ever see in a slick product demo. And these effects just keep rippling outwards. When access to reliable energy becomes a key ingredient for economic power, well, it starts to rewrite geopolitics. Countries with abundant baseload power gain this massive strategic advantage, which only intensifies the global competition for resources that was already happening. So the takeaway here is that we really need to adjust our mental model of what AI is. It's not weightless. It has a heavy reality. The future of intelligence at scale isn't just about who writes the best algorithms. It's about what we are willing and able to physically power. And this is the crucial difference. Unlike software, which you can update or patch on the fly, infrastructure is sticky. A power plant built today is going to be operating for decades. The energy decisions being made right now to fuel AI's growth are literally locking us into pathways with consequences that are very, very difficult to reverse. So let's end on this thought. If the future of AI isn't just being written in code, but is being physically built with steel and concrete and power lines, who gets to decide what we build and where we build it? These hidden physical drivers are just one of the core ideas from the book that inspired this whole explainer, The Quiet Disruption. It digs into these quiet consequences alongside other major shifts in work, trust, and power. So if you want to go deeper, the book is available right now on Amazon. We've dropped a link for you right in the description.